Alright, I want to have a quick talk with you about the relationship between these three things: degree, end behavior, and the leading coefficient. And really, as far as the leading coefficient, we're just talking about whether or not it's positive or if it's negative. Now remember about the degree. Say if I have, let's say, 3x to the 5th power plus 4x squared minus 1. What is the degree of this polynomial? Do you remember? The degree is 5. Alright, so remember that the degree is just this highest exponent. So this would be degree 5. Now for this little talk, I'm just only going to deal with a monomial. So for example, x to the 5th power would be obviously degree 5. Now, if I draw you a parabola like this, what degree is this? Hopefully you said this is degree 2, because you're looking at this and you're thinking, oh, that's like having x squared. How would things change if I drew it upside down like this? Alright, how will that change the equation? I would have to put a negative sign in front. Okay? Now that negative sign, now I'm talking about the leading coefficient. Okay? So this upward facing parabola is a degree 2, alright? You know it's quadratic, it's like x squared. But you also know that the leading coefficient is positive because it's upward facing. If it's upside down parabola, you know it's degree 2, and you know it is a negative leading coefficient. That's why it's upside down. Of course, end behavior, on the left it rises, on the right it rises. And for this case, on the left it falls, and on the right it falls. Okay? Now, the reason why this is so important is because it turns out that all even degree polynomials have the same end behavior. Let me write that down. For example, so we have x squared has this end behavior. Rises on the left, rises on the right. Well, take a look at x to the 4th power, alright, even degree. The end behavior would look like this. Okay, notice again it rises on the left, rises on the right. Take a look at x to the 6th power. Alright, if the degree were 6, it would be like this. Okay, so hopefully you can see that the higher the degree gets, the more waves I have in it, but the end behavior remains the same. Rises on the left and rises on the right. Well, I'm saying rises, but that's only if the leading coefficient is positive. So notice that all of these have a positive leading coefficient. If they were negative leading coefficient, then they'd be the same thing, only upside down, like this. Okay, so this is what negative x to the 4th power would look like if that was the degree, and this is what a negative leading coefficient x to the 6th power problem would look like. Okay? So notice that all of the even powers work the same. Just pay attention to if it's rising, then that's going to mean it's a positive leading coefficient. But if it's falling, alright, falling on the left and the right, then you know it's a negative leading coefficient. Okay, so they all work the same. Alright, so really just memorize how a parabola works, and you know how all of the even powered polynomials work, even degree. Alright, now what about odd? Alright, well this will be new to you, especially if you didn't watch the homework video last night. Shame on you. If you did, then you're feeling pretty smart right now because you already know this. This is what your classic cubic graph looks like. Alright, so this would be like a positive degree 3. It helps me if I realize that this looks a lot like a capital letter N. Okay, so if it's a right side up cubic function, if it's positive, it's going to look like a capital letter N. But guess what? All odd degree polynomials have the same N behavior like this. Technical difficulties. So I have x to the third power looking like a capital N. Let's see, what if I had x to the fifth power? Well, x to the fifth power, the classic graph for that would look something like this. Okay, so here's what a fifth degree polynomial, it would have N behavior like this. Can you see how the N behavior is the same as the cubic? It falls on the left and it rises on the right. Falls on the left, rises on the right. Alright, so all of the odd degree polynomials have the same type of N behavior. Let's do one more. Okay, if I wanted to do x to the sixth power, seventh power. Alright, the next odd one. Alright, notice that it has the same type of N behavior. Okay, so it's going to be like this. Alright, it just has an extra wave in it. Okay, so your classic degree 7 polynomial would have this type of N behavior. Alright, so notice all odd degree polynomials have N behavior like x to the third power, like a cubic. So if you memorize how a cubic works, falls on the left, rises on the right, then guess what? You've just memorized how all of the odd ones work. Now, again, it's a difference between the positive versions, alright? And again, I'm talking about leading coefficient here, okay? Positive or negative. These are all the positive leading coefficient versions of this, alright? Like a capital N, a right side up N. So, you can bet that if I drew an upside down N, then that would be like a negative leading coefficient. So, if I drew an upside down N, something like this, alright, see how it still sort of looks like an N, but it's upside down? This would be like having a negative cubic, alright? This would be the N behavior of a negative cubic, an upside down N. Alright, so all of the negative leading coefficients of these odd degree polynomials will be the same as this now. Okay? So for example, x to the negative x to the fifth power would work like this. Okay? Notice how the N behavior is the same as negative x to the third power. Rising on the left, falling on the right. Okay, and one more. If I wanted to look at negative leading coefficient, alright, negative x to the seventh power, it's going to have the same leading coefficient as these, the same N behavior as these, just with an extra wave to it. So it would be like this type of a deal. Okay, so again, all of the N behavior, all of the odd polynomials have the same N behavior. Alright, just pay attention to if it has the N behavior like a right side up N, then that means that's the positive leading coefficient. If it has N behavior like an upside down N, then that's going to be your negative leading coefficient. Yes, quite. Alright, let me quiz you. So if I draw you a graph, you should be able to tell me whether the degree is even or odd, and you should be able to tell me whether the leading coefficient is positive or negative. Okay, so here's a graph. Crazy graph, crazy graph. Okay, degree. Is this even degree or odd degree? Alright, I'm hoping you said that this is even degree. See how both arms are reaching in the same direction? That only happens with even degree, okay? Because that's how a parabola works. Alright, if I drew a big old parabola over this, you would have the same end behavior. So a parabola is even, so this must be even. Alright, now I gave you a big hint on the leading coefficient. Is this a positive leading coefficient or a negative leading coefficient? Alright, this is a negative leading coefficient because of the way it looks upside down. Okay? Let's do one more of those. Look at this graph. Is this even degree or odd degree? Alright, hopefully you said this is odd degree. You know because of the end behavior. One arm's pointing down, one arm is pointing up. They're not going the same direction. When they're going different directions, that's how odd degree polynomials work. Now, is this a positive leading coefficient or a negative leading coefficient? Alright, at a glance, I can tell you that this is positive leading coefficient because think about the capital letter N. Okay? A capital letter N, alright, right side up, has the same end behavior as this function. Okay? A capital letter N falls on the left and rises on the right, just like this. So a capital letter, a right side up N is positive. So that tells me that this is positive. Okay? If it had the end behavior like this, this would be the negative version because it's like an upside down N. Okay, boom, there it is.